All right, let's look at the midpoint rule. All right, so what we want to do is we want to approximate the value of the definite integral, which represents the area of this shaded area there. All right, so what we want to do is just like before, we're going to chop things into skinny pieces. So we're going to just, slice it into n skinny pieces, just like before. Right, so dot, dot, dot. And let's say this is the last piece. Right? So we're going to use an approximating rectangle, but to determine the height of each rectangle, we're going to use a midpoint. Right? So we have, right, just like before, we're going to name it. So A is x0, and the next one is x1, x2, and the last one is xn, and here's xn minus 1. All right, so instead of using the left endpoint or right endpoint, we're going to use the midpoint. All right, so the midpoint, it's going to be, so let's say for the first one, midpoint of our first one is right around here. So the notation for this is we're going to use x1 bar because it's the first one. So bar means it's the midpoint, right? So next one is so notation is x2 bar, right? So the formula for midpoint would be just midpoint is just the average. So we know that here, if you want to find x1 bar, which is just going to be the average between x0 and x1. So add them up, divide by 2. And x2 bar is just the average between x1 and x2 over 2. Right? So you're detecting a pattern here, right? So if you want to find, say, let's say xi, bar is going to be xi minus 1 plus xi over 2. Right? So that would be the formula for midpoint. Right? So we're going to use a midpoint. So go straight up here and go straight up. And then use that as the use the function value there as the height for the height of a rectangle, right? And here for the second one, you go up and use that as the height to determine the rectangle, right? So as you can see, so base times height, so you have base is delta x, just like before. All right, for the first one, we're gonna the height is f of x1 bar. Right, we're using the midpoint. Right, for the second one, we're gonna use f of x2 bar as the height, and base is of course delta x. And the last one, right? Last one is of course it's going to be xn bar, right? So which looks kind of like that. All right, so area is of course f of xn bar delta x. Right? And as usual, we can pull out delta x. So we have delta x is pulled out. We can write it as f of x1 bar plus f of x2 bar, and so on, all the way up to f of xn bar. All right? And we can use also a sigma notation, summation notation to rewrite this, since there's a nice pattern going. So we're going to say, all right, so each one is going to have a form of f of x I bar times delta x, right? Then index starts from 1, so that's the first one, and the last one is n. So we're going to sum up. So using a sigma notation, I is going to start from 1 and ending at n. So this is another notation. And we're going to have to explain how to find the midpoint. So we can say where xi bar is just simply the average between xi minus 1 and xi over 2. All right, so this is called the midpoint rule. All right, so let's do a simple example. Let's find the midpoint rule, M3. So M3 means that we're going to split that rectangle pieces into 3 pieces. All right, then for integral from 1 to 7 x squared dx. All right, so let's find delta x first. So we know that here a would be 1 and b would be 7. All right, so we can find delta x to be, all right, b is 7, a is 1 over n. So n is 3 in this case. So divide by 3. So it's a 6 over 3. So delta x is 2. Right? Then let's find the midpoint. So the interval is going from, so I'm going to just do a number line so it makes it easier. All right, so here's a number line, and we're going from 1 to 7. So you have a 1 to 7, so right here. And the delta x is 2, so it's going to go to, so 1 to 3, so chop that into 3 pieces. So that will be 3 there, and then that'll be 5 there, right? So the midpoint that we're looking for would be, so midpoint is going to be sitting right here. So this is going to be our x1 bar, and here is going to be our x2 bar. And this is going to be x3 bar, right? So we can easily find x1 bar is the average between 1 and 3. So 1 plus 3 divided by 2 is 4. And 3 plus 5 divided by 2 is, oh, actually, I messed that up, didn't I? Let's see. It's actually 2 there, right? And this is going to be 4 there. And this is going to be at 6. Right? So if you want to find M3, right, this is all you need to do. So you need to do M3 is equal to, right? Right, first you have to do f of x1, which is 2, plus f of x2 bar, which is 4. And then we have to do f of 6, and then times delta x, right? And f of 2, f is right here. F is just the integrand, so that's the function. All right, so f of x is x squared, so f of 2 is 2 squared, so that will be 4. And 4 squared, so that's 16. And 6 squared would be 36. And then we're going to have to multiply by delta x is 2, which we found there. All right, so this is going to be, so let's see, if we do 4 plus 16 is 20, and 20 plus 36 is 56, times 2, so it's 112. Right? So that's the value of the M3. All right, that's it. I hope that this was clear.